Assalamualaikum and have a good day to Dr. Farizan and everyone. Our group will present a journal entitled Low Cost Smartphone Control Potential State based on Arduino. So let's go!
Firstly, is objective or purpose. The main purpose of the measurement system described in this article is to act as a tool for teaching electrochemistry fundamentals and application using a low-cost smartphone control potential state. A potential state is a voltage source that adjusts its output potential based on circuit resistance change. In electrochemistry experiment, potential state regulate current to maintain a constant potential across an active cell following Ohm's law. Based on the article, Pakari state the potential state in the system was tested against a commercial potential state using cyclic voltammetry with a ferrocyanide or ferrocyanide redox couple and a glassy carbon electrode. The result from Pakari state was similar to those obtained from the commercial potential state, indicating comparable performance. Next is physical parameter. Based on the information provided in the article, the physical parameters or variable that the system is designed to measure are firstly, current, second, voltage, third, scan rate, for operating voltage window, 5 potential step, and lastly is cycle number.
Okay, next about measurement system elements. A. Conversion of the sensor or transducer from physical parameters into electrical signal. The sensor or transducer used in the system is working electrode, which is used to measure the electrochemical response of the sample being analyzed. The working electrode is made of a conductive material like pencil graphite PG4B, and it is immersed in the sample solution. When a potential is applied to working electrode, it generates a current that is proportional to the electrochemical reaction occurring at the electrode solution interface. B. Signal conditioning process used in the system. The signal conditioning process used in the system involves the use of a trans-impedance amplifier to amplify and convert the current signal generated by the working electrode into a digital signal that can be processed by the ADC module of the Arduino nanoboards. The trans-impedance amplifier is used to improve the signal-to-noise ratio and ensure that the measurements are within the range of ADC modules. The measurement system includes voltage converters and operational amplifier for signal conditioning. C. Signal processing performed by the system. The signal processing performed by the system involves the conversion of the analog measurement collected by the trans-impedance amplifier into digital signal using the ADC module of the Arduino nanoboard. The digital signals are then transferred to the smartphone via Bluetooth module where they are processed to display the experimental data in real time. The specific computation or manipulation performed by the application may include data visualization, scaling or normalization of the measurement, and potentially applying an algorithm or mathematical operation to analyze the data. Okay, next, D. ADC used in the system. ADC module of the Arduino nanoboard is used, which is responsible for converting the analog measurement collected by trans-impedance amplifier into digital signals. ADC working explanation. First, sampling. The ADC samples the analog signal at regular intervals, capturing the measured voltage or current from the electrochemical cell. Second, quantization. The sample analog signal is divided into discrete levels, representing specific digital values. The number of levels determines the ADC's resolution. Third, conversion. The quantized analog signal is converted into a digital representation. The ADC assigns a digital value to each quantized level based on the measured voltage or current. And fourth, digital output. The ADC output the convert digital values, which can be further processed, analyzed, visualized, or stored. Okay, next E. How the process signal is displayed or stored. The process signal is displayed in real time on the smartphone application, which is called Pakari Lab, which receives the digital signal and process them to display the experimental data. The application provides a graphical interface that allows the user to visualize the data and perform basic data analysis. Also, can export into .csv file. F. Feedback or control element system. The system does not include a feedback or control element, as it is designed primarily for data execution and analysis. However, the smartphone application provides a user interface that allows the user to control the experimental parameters such as the applied potential and measurement time, and to adjust the setting of the potential state. The system wireless transmission and control feature contribute to its operation by offering a portable and economical platform for electrochemical measurements. Users may use the Bluetooth module to operate the potential state, and receive data in real time without the need for physical connection between the potentiostat and the smartphone. This feature enhances the potentiostat usefulness, autonomy and portability while maintaining its tiny and portable size.
Hi, my name is MAZARAH, and so this part I explain a little bit about the block diagram of Potentiostat. Okay, so in the system, electrochemical response as input. First, it is transferred to the working electrode. So this electrode here is the sensor used to measure the electrochemical response of the sample. And then we have transimpedance amplifier, that is the signal conditioning element, where it involved in amplifying and converting the current signals generated by the working electrode. The signal processing performed by the systems involve the conversion of the analog measurements collected by the transimpedance amplifier into digital signals using the ADC module of the Arduino Nano board. Okay, so the digital signals are then transferred to the smartphone via Bluetooth module. So, how does the system display the data? Okay, so here the process signal is displayed in real time on the PakariLab smartphone application, which receive the digital signals and process them to display the experimental data.
Okay, let me explain about the bill of material. This system utilizes Arduino, which is a microcontroller that controls the potential in the 3-electrode electrochemical cell. Arduino has digital and analog pins for information input-output. Furthermore, the transimpedance amplifier captures analog measurement from the working electrode and amplifies the current signal into a voltage signal. This system also uses the ADC module of Arduino Nano, which converts analog measurement from the transimpedance amplifier into digital values by quantizing the continuous signal. Next, we have the Bluetooth module, which is a wireless connection that transfers real-time digital signal from the ADC module to a smartphone application, establishing a connection between the potentiostat and the smartphone. This system also includes a smartphone application, PakariLab. The application controls the potentiostat and receives data. It is compatible with Android 7.0 or higher. The application allows method selection, parameter input, and real-time data display. This system utilizes an electrochemical system that consists of 3 types of electrode: working, referent, and counter. The working electrode made of conductive material is where the reaction occurs. The referent electrode provides a stable reference potential for measurement. The counter electrode completes the circuit and maintains a constant potential. These electrodes are essential for controlling and measuring electrochemical reaction. In addition, a bismuth film is included, enhancing electrical response, aiding in the deposition of the heavier metals on the working electrode and enabling improved detection of lead and cadmium. These electrodes and the bismuth film ensure precise and reliable measurement in the electrochemical cell, especially for detecting and analyzing lead and cadmium.
In this slide, I'll talk about the application of the system. It has various real-world applications, such as in research and development. The system data is electrochemical research laboratories, enabling material and device development. It supports multiple techniques like cyclic voltammetry and chronometry through the user-friendly smartphone application interface. This simplifies the experimental setup, data analysis process, and electrochemical system optimization for efficient research. The second application is in education and training. The system facilitates electrochemical education and training. PakariLab enables students to interact with the equipment, select different electrochemical methods, input functional parameters, and view real-time experimental data. This hands-on experiment enhances understanding, encourages active learning, and suits users of all levels for its simplicity and accessibility. The third application is in quality control and process monitoring. The system aids in electrochemical quality control and process monitoring in industry like battery manufacturing or corrosion testing. It provides real-time monitoring of electrochemical parameters like potential, current, and scan rate during the manufacturing process, ensuring consistent product quality and optimizing process parameters. The wireless communication enables remote monitoring and control, enhancing efficiency and convenience in industrial application. And the last application is in portable and field application. The system compact and portable design is ideal for field use. It enables research and professionals to conduct electrochemical measurement and data acquisition on-site, eliminating the need of complex setups. It finds valuable application in environmental monitoring, water analysis, or on-site electrochemical analysis across industry.
That's all from us. Thank you.